Hi, everybody. Uh, this next video, the second in a series of 5, is going to look at single variable examples and calculations. All right, and we're going to cover calculations. I'm not going to ask you to do any calculations on homework assignment or exams, but I do like to cover the calculations because it makes it so that we get a better understanding of where numbers come from, so it's not like this magical thing. There we go. So we're going to talk first about what's called the classic approach to mediation. This comes from an article by Barron and Kenny. It came out quite some time ago. And this article is such a classic. It's got over 90,000 citations, which is just mind-boggling. I will say some of the advice offered in this seminal article is now being questioned, but it is a very common approach, and the things that are being questioned don't make the approach invalid. It just means that this approach is probably a little less flexible than it should be for determining mediation. This is typically this process. The Barron and Kenny approach is typically designated as 4 steps. In the first step of the process, we show that the predictor is related to the outcome. Here we run a regression analysis where we're predicting the dependent variable from the predictor. This creates the C path, that total effect. If there's no total effect, Barron and Kenny say, hey, stop here. You don't have any effect to mediate. There is some question around that we'll talk about at the very last set of slides. Step 2, show that the predictor correlates with the mediator or is related to the mediator. Here you can use regression to predict the mediator from the predictor. That would be path where we would derive path A. The third one, show that the mediator affects the outcome variable in the presence of a predictor. What we're doing there is we are establishing how strongly the mediator predicts the outcome, and that's where we're going to get with the predictor also in the equation. So this is a multiple regression. And that's where we're going to get path B. And then finally, we're going to calculate the mediated effect or the indirect effect, AB, and test it for significance. We're going to see that we'll take information from 3 separate regression analyses here, and that is the way that people used to do this. They would start off, first step requires a regression, second requires a regression, third requires another regression, and then the fourth step involves additional calculations. To kind of give you the different formulas we'll be dealing with. The indirect or the mediated effect, that's just A path times the B path, or similarly, we can take the C path, which is our total effect, minus C prime, which is our direct effect. The Sobel test takes that indirect effect and it divides it simply by a standard error term to get, in this case, a Z value. And that's really the basics of any test statistic. We're dividing an effect by its standard error. The standard error, you can see that it's calculated by taking a handful of values. All of these values are going to come from different regression equations. For example, A is simply the A path. The standard error of A is going to be the standard error that we get for our regression coefficient for that path A. Same thing for B. Those both come from regression equations. One thing about this equation that sometimes trips people up is you can see that A squared is multiplied by the standard error of B squared, and then when we move over B squared, standard error of A squared. And again, we can get all of that from our regression output. One thing to note, in some sources, the formula here is noted as the SE is noted as S. I don't like that. I like SE to be a little bit more precise, that this is a standard error, not a standard deviation. This can also be expressed as a confidence interval, which will be much more likely to see for indirect effects, and that's just A plus B times Z of 0.95. That is the Z value that captures 95% of the normal distribution. You may remember from your statistics class that is always the same value. It's 1.96. And then when we multiply that by our standard error term. And again, that's a real classic confidence interval formulation. We've got some value from a table, either a Z or a T, generally multiplied by a standard error. One thing to note here is that these approaches are maybe a bit outdated. I use this approach, but it is widely criticized. It's nice as a calculational example to show you where numbers come from. More commonly, we'll be using bootstrapped approaches. One thing I want to note about the confidence interval here, a little aside, if you're not calculating for things to be terribly precise, you just want to get a ballpark on what your confidence interval is. Generally, most people would say just double the standard error. And the reason why if they say double the standard error is because if you're using the Z distribution, it's almost 2.0. If you're using a T distribution, those T values, unless you have a very, very small sample, are going to hover around 2. So doubling it gives you a nice back of the envelope estimate without having to go hunt down a Z or a T table. All right, here's the first step in our analysis. Step 1 is predicting intergroup attitudes from quality of contact. So just a simple regression predicting attitude from quality. Those are the names of the variables there. The estimate that we get, 0.47338, I bolded that on there. That is our C path. That is our total effect. What does this tell us? Well, it's a significant effect. So it tells us that we've met the first criteria that we have to, contact and attitudes have to be related to each other. So there is an effect to be mediated. And it also tells us, since it's a positive coefficient, that greater quality of contact relates to more positive attitudes. That's not a surprise. That's well known throughout the contact literature. We're interested in whether there are effects that mediate that. So step 2, and I'll have to move my face around a little bit here to stay out of the way. Step 2, we predict the mediator anxiety from contact, from the X variable. And that is getting at this A path. So that's where we're going to get that information for the A path. So here we see what's a little strange is that the mediator has become in our regression equation what we're predicting, or has become a dependent variable in our regression equation. So we're simply predicting anxiety from quality of contact. And we get a couple of values. We get A, which is the coefficient. And we also get the standard error of A. And you can see that that's listed right next to the estimate, value of 0.06716. Those are going to be values that we're going to use in future calculations. So big question here. We also want to verify, yes, this is a significant relationship. Is contact related to anxiety? Yeah. Greater quality of contact leads to reduced anxiety. We know that because we have a negative coefficient here. So again, two of the values that we're going to use for future calculations. We've also established that the criteria for step 2 is true. Step 3. In step 3, we're going to predict Y, from both X and M. That is, we're predicting our outcome from the mediator and from the predictor variable. This is where we get the B and the C prime paths. And you can see here, this is just a standard multiple regression with both of our variables, the predictor and the mediator, just entered together as regular old predictors. That's where we're going to get 3 of these estimates. We're going to get the B path, its standard error, and we're also going to get C prime, which is the direct path. Which is the direct effect, I should say. You see the direct effect is 0.25. What does this tell us? Well, it tells us, relevant to step 3, because we have a significant coefficient for anxiety, that greater anxiety is related to less favorable attitudes, even in the presence of this contact variable. So far, we've established the first 3 aspects of the Barron and Kenny criteria, but what about the 4th one? In the 4th one, we want to establish whether our mediated effect is statistically significant. Again, number of newer ways to do this. The computer will handle this for you. You can see I've reproduced some of the values on the right-hand side just for our reference, C, A, the standard errors, and all those things. See the calculation of the indirect effect simply takes the A path times the B path. Or another way you can get that is you can take the total effect and subtract from it the direct effect. Both of those yield exactly the same value, 0.2281. The size of that is not really readily interpretable because it's It's an unstandardized coefficient, so don't worry about interpreting that. The standard error, you can see the standard error calculation there. It's the A path times the standard error of B squared. Then the B path times the standard error of A squared. And I took some liberties with rounding here just to give you smaller values to deal with. And then we take that to the confidence interval. We plug in A plus B, 1.96, that's Z of 0.95 value, times our standard error. And it gives us a confidence interval that goes from about 0.5 to 0.30. The way to interpret this confidence interval, if there's no indirect effect, the null hypothesis would be that that AB in the population would be equal to 0. So if this confidence interval excludes 0, if it doesn't contain 0, we reject the null hypothesis, just like we would do with a t-test or a correlation or other procedures of that nature. So here we have now established that there is a significant mediated effect. So we established, just to recap, we established the predictor was related to the outcome. Contact and intergroup attitudes were in fact related. There was an effect to mediate. We established that the predictor and the mediator, contact and intergroup anxiety in this case, were related. We established that the mediator related to the outcome in the presence of the predictor. And then we established that the indirect effect was statistically significant, suggesting that anxiety mediates the contact attitude relationship. A couple of things here. We really want to make sure that we avoid causal language. We want to, we don't want to talk about anxiety being the root cause or contact causing anxiety to go lower. Again, that's something that would only be warranted if you're doing an experiment. We're establishing the statistical evidence that would be necessary but not sufficient for determining mediation, but we are not in fact determining causal mediation, only the statistical evidence for it. All right, we'll stop here, and in the next set of slides, we will talk about single variable examples using R.